ICS here, correct? Now it is the, we will briefly go through the what is the PLC and the SCADA here. So what is the PLC and the SCADA? These are the table of the contents here. What we are learning here: PLC, SCADA, and PLC RTOs here. Architecture of the SCADA and components of the SCADA and the features of the SCADA system here. Because in the examination what they will do, the question is explain the ICS, how it is used in the industries, and also explain one of the component of the ICS and SCADA. One of the component is what? Either you have to explain the SCADA or the PLC. First you have to explain what is ICS and which are the different components of the ICS, and in detail you have to explain any one of the components. In detail you have to explain any one of the components. Therefore, now we will go through those PLC and the SCADA here. Okay. Now PLC, what is the PLC here? It is a program logic controller. PLC is a ruggedized industrial digital computer. Correct? Here ruggedized means what? Here it is like a rough and tough. It can be used in the industrial environment here. It can be used in the industrial environment and also computer designed for the purpose of the control and the automation of the electromechanical process. For the controlling and the automation. Mainly PLCs are designed for the controlling and the automation processes here. PLCs are widely used in manufacturing, assembly lines, robotic devices, and any process that requires high reliability control and ease of programming and process fault diagnosis. Means easily PLC can be programmed. Already you know your written programs are so that easily those can be programmed, and also fault finding is also very easy, correct? And also diagnosing the faults. Those are the very easy processes here. Therefore, those are the advantages of the PLC here. Next, key features of the PLC here. That is, these are the rugged design, means PLCs are designed to operate in the harsh industrial environments. Those are used to operate in the very harsh and full temperature high full vibrations correct, high temperature, high vibrations, and also the humidity level sometimes, noise. Right? In those harsh environment also, if you install those PLCs, they will work correctly. Okay. Next, industrial ones with the extreme temperature, humidity, dust, and the vibrations. In those environments also, they will work here. Next, real-time operation. The PLCs will do the real-time operations. That is, PLCs can respond to input conditions in the real time, making them suitable for the time-sensitive applications. Means, input and sense marker immediately it will respond. Correct? Real time, on the real time it will immediately respond and it will make the controlling of that particular process here. Therefore, it is the main feature of the PLC, it's the real time operation, and also mainly it is used in the time-sensitive applications. Time-sensitive applications ಅಂದ್ರೆ ಈಗ ಒಂದು ಡಿಟೆಕ್ಟ್ ಆಯಿತು, ಅದು ಕಡಿಮೆ ಆಗ್ಬಿಟ್ಟು ವಿದಿನ್ ಸೆಕೆಂಡ್ಸ್ ಅದು ಆಪರೇಷನ್ ಕಂಟ್ರೋಲ್ ಆಗಬೇಕಂತ ಇಮಿಡಿಯೇಟ್ ಕಂಟ್ರೋಲ್ ಆಗಬೇಕು, ಅದು ಹೌದಾ? ಪರ್ಟಿಕ್ಯುಲರ್ PLCs we can use. ಈಗ ಅದು ಯಾವುದೋ ಒಂದು ಎರರ್ ಡಿಟೆಕ್ಟ್ ಆಗಿ ಅಥವಾ ಏನು ಕಂಟ್ರೋಲಿಂಗ್ ಪ್ರೊಸೆಸ್ ಡಿಟೆಕ್ಟ್ ಆಗಿ ಅದು 1 hour ಬಿಟ್ಟು 2 hour ಬಿಟ್ಟು ಕಂಟ್ರೋಲ್ ಆದಾಗ ದಟ್ ಇಸ್ ಆಫ್ ನೋ ಯೂಸ್. Correct? Therefore, immediately that should be handled here. Immediately that problem should be handled. Therefore, for those time-sensitive applications, these PLCs are used here. Next is the programmable. As you know, PLCs are the easily programmable here, and different types of the programming methods are there for the PLCs. Which one you have used in the lab? Among these different methods in the lab already you did. Which method you have used? Ladder diagram. Correct? Again, apart from the ladder diagram, again which methods are there? See here. That is the ladder logic function. One ladder logic. Second is the functional block diagram. That is also one of the method to program the PLC. Functional block diagram, and also the structured text. That is also one of the method to program the PLC. And next is the instruction list. That is also one of the method, and also sequential function chart. These are the different methods. You can adopt any one of them. It is not that compulsorily you have to use the ladder diagram only, or you have to use the functional block only, like that. These are the numbers because it is very flexible. Programming is very flexible here for the PLC. It can use any one of the method for the programming here. Okay. Next, modular structure. It is also one of the advantage. It is having the PLCs often have the modular design, allowing the addition or replacement of the input/output modules, communication modules, and other components. Means modular design is what? All the whatever the parts are there, those are not connected in series or like that. Those are divided into some sub modules here. This is one module, module 1. Here some components are there, or the devices are there. This is the module 2. Here some devices are there. In the module 3 some devices are there. In the module 5 some devices are there. Like this. This is divided into number of modules. And in future if you want to any device means easily you can add through that modular design section, or if you want to remove any device means easily you can remove. But if that modular structure is not there, continuously those devices are connected, means what will happen? Handling of those devices and adding or deleting of the device or removing the device is difficult there. But in the PLC, the structure is modular structure here. Correct? It is the modular structure. Therefore, the benefit is what? Allowing the addition or replacement of the input/output modules. We can add the input/output module. We can remove them, and also the communication modules and other components very easily due to its modular structure here. Next is the connectivity. How these PLCs can be connected here? Connect to other devices and systems through the various communication protocols. Correct? Through the various communication protocols, these are connected, such as the Internet, Modbus, Profibus, and the device net. These are some of the protocols which are used to connect PLC to the devices here. Through these protocols, here the PLC can be connected here. Next, the brief block diagram of the PLC. If you go. First is as it is defined, PLC is nothing but it is just a computer only. Correct? PLC is nothing but it is a special type of the computer which will operate in a harsh environment also. Harsh industrial environment also. Therefore, if you go through the block diagram here, CPU, memory, input, output, power supply, the communication device. Correct? These are the blocks of the PLC. Different blocks of the PLC. ಈಗ ಒಂದು ಏನೋ ಬ್ಲಾಕ್ ಡಯಾಗ್ರಾಮ್ ಬಂತು ಎಲ್ಲರಿಗೂ ಖುಷಿ ಆಗ್ಬಿಟ್ಟು ಒಂದು ಏನೋ ಡಯಾಗ್ರಾಮ್ ಬಂದು ನಮ್ಗೆ ಹೋದ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡೋಣ ಅಂತ ಹೇಳ್ಬೋದ ಮತ್ತು ಬರೀ ಡಯಾಗ್ರಾಮ್ ಲಿಸ್ಟ್ ಇತ್ತು ಹ್ಯಾಕ್ಟಿಕ್ ಆಗಿ ಹೋಗ್ಬಿಟ್ಟಿತ್ತು ಬರೀ ಡಯಾಗ್ರಾಮ್ ಲಿಸ್ಟ್ ಇತ್ತಂತ ಇವಾಗ ಒಂದು ಡಯಾಗ್ರಾಮ್ ಕಾಣ್ತಂದ್ರೆ ಒಂದು ಮರುಭೂಮಿ ಒಳಗೆ ಒಂದು ನೀರು ಸಿಗೋದು ಅದು ಅನಿಸ್ತೇನೆ ಎಲ್ಲರಿಗೂ ಏನೋ ಕಣ್ಣಿಗೆ ಚಲೋ ಕಾಣ್ತದೆ ಅಂತ ನಾವು ಸೇರ್ ಹಿಯರ್ ದಿಸ್ ಇಸ್ ದ ಬ್ಲಾಕ್ ಡಯಾಗ್ರಾಮ್ ಆಫ್ ದ PLC here. This is the block diagram of the PLC. Now if you observe the particular explanation here, first is the central processing unit, CPU. Correct? The central block is the central processing unit of the CPU. It is also called as the brain of the PLC because all the processing jobs are done in the CPU. Okay, brain of the PLC which processes the input, executes the control program stored in its memory and sends the appropriate outputs. Correct? It will process the input, whatever the inputs are fed to the PLC, those are processed here, and also the executed the instructions in the memory, and the data is appropriate outputs are generated and those are given to the outputs here. Next is the power supply. Provides the necessary power for the PLC and its components because different components or the different parts needs some different voltage levels here. Power supply. Therefore, that power supply unit will generate all those power units, and those are distributed to different ICs, different parts here. Next is the input/output modules here. That is input module and the output module. In the input/output module, interfaces the PLC with the external environment, receiving input signals. Input module ಅಂದ್ರೆ ಯಾವಾಗ ಹೇಳ್ರಿ PLC input module ಅಂದ್ರೆ ಈ external world ಗೆ ಕನೆಕ್ಟ್ ಆಗಿದೆ. ಹೌದಾ? If you connect to the external worlds, examples are the sensors and the switches. Sensors ನೋಡಿ external world ಇಂದ sense ಮಾಡಿ ಒಳಗೆ ಹಾಕ್ತಿದ್ದಾರೆ. Correct? Sensors and the switches are the example for the input module here. Similarly, output module was sending the output signals. ಎಲ್ಲ ಜನರೇಟ್ ಆಗಿ ಪ್ರೊಸೆಸ್ ಆಗಿ ಔಟ್ಪುಟ್ ಏನು ಬಂದಿತ್ತು ಎಲ್ಲಿ ಕಳಿಸಿರ್ತದೆ ಔಟ್ಪುಟ್ ಮಾಡಲ್ ಕಳಿಸಿರ್ತದೆ ಔಟ್ಪುಟ್ ಮಾಡಲ್ ಎಕ್ಸಾಂಪಲ್ಸ್ ಯಾವ್ದು ಹೇಳ್ರಿ ಆಕ್ಚುಯೇಟರ್ಸ್ ಅಂಡ್ ರಿಲೇಸ್ ಅವು ಏನಾದರೂ ವಾಲ್ವ್ ಕ್ಲೋಸ್ ಮಾಡಬೇಕು, ಸ್ಪೀಡ್ ಹೆಚ್ಚು ಮಾಡಬೇಕು, ಸ್ಪೀಡ್ ಕಡಿಮೆ ಮಾಡಬೇಕು, ರಿಲೇ ಆನ್ ಆಗಬೇಕು, ಆಫ್ ಆಗಬೇಕು. ಆಲ್ ದೋಸ್ ಆರ್ ದ ಔಟ್ಪುಟ್ ಮಾಡ್ಯೂಲ್ಸ್ ಹಿಯರ್. ಇನ್ಪುಟ್ ಅಂದರೆ ಸೆನ್ಸ್ ಮಾಡೋದು, sensing and switches here, switch on or switch off, and those are the input modules. Next is the programming devices. That is the programming devices used to write, edit and upload the control program to the PLC. It can be a PC or a dedicated handheld programmer. ಅಂದರೆ ಈಗ ನಾವು ಏನು ಪ್ರೋಗ್ರಾಮ್ ನಮ್ಮ PLC ಕಿಟ್ ಇರುತ್ತೆ, ಅರ್ಧ ಮಾಡ್ಯೂಲ್ ಇರ್ತೈತಿ, ಅದರ ಪ್ರೋಗ್ರಾಮ್ ಹೆಂಗೆ ಬರಿಬೇಕಾ ಅದನ್ನ ಬರೀಲಿಕ್ಕೆ ನಾವು ಏನು ಮಾಡ್ತೀವಿ, ವಿಲ್ ಟೇಕ್ ದ ಸಪೋರ್ಟ್ ಆಫ್ ದ ಕಂಪ್ಯೂಟರ್. On the computer we will write and we will upload that to the our kit, PLC kit. Correct? We will upload that to the PLC kit after entering the program into the computer. Therefore, programming modules are the either the dedicated computer or the dedicated handheld program. Other some of the program or some of the device here. Okay. Next is the memory. What is the function of the memory? It will store the control program and data. It will storing the data as well as that programming, this one control programs. It includes both volatile memory, RAM and non-volatile memory. These are the examples: EEPROM, flash memory. All these type of memories are there in the memory unit here. This is the explanation for the basic block diagram of the PLC. Okay, in the examination, as I said, in the ICS, explain the ICS. Industrial control system, different components are the different functional key functional parts there, and also explain any one in detail. And then you PLC nu detail ಆಗಿ explain ಮಾಡಬಹುದು. What is PLC? ಅದೇನು ಮಾಡೋದು ಬ್ಲಾಕ್ ಡಯಾಗ್ರಾಮ್ ಆಗಿ ನೀಟಾಗಿ explain ಮಾಡಬಹುದು. Next is the second part is the SCADA. SCADA is the, that is the, SCADA is what here? Supervisory control and data acquisition system. SCADA is nothing but the supervisory control and the data acquisition system. These systems, what is the main function of the SCADA? Avage discuss ಮಾಡಿದ್ರು. What is the main function? Collecting the data from the various sensors and the devices and giving to the centralized data unit there for the processing purpose. Okay. Now there is the gather the data from the various sensors and the devices and present it in the centralized location for the monitoring and the control here. For monitoring purpose and for the controlling purpose. Now PLCs are a common unit of automation. Here, the PLCs are the common in the particular SCADA, which are the different parts are there to collect those data here. PLCs are also present in the SCADA and also the RTUs, the remote terminal units. Means SCADA will make use of this PLC and RTUs to collect the data because those are installed there only near the devices. Right? From those devices, from the PLC and from the RTUs, the SCADA structure will collect the information. It will collect the information. For example, you just go to the diagram here. Here, this is the full SCADA unit here. Okay. Here, if you observe here, this is a human machine interface, HMI. Correct? Where we can communicate through that particular system. Okay. Now this is the master unit here, communication network, and here if you observe PLC, RPUs, remote terminal units. Again, one more PLC. Again, to that end here we are having the sensors and the actuators. At the end we are having the sensors and the actuators here. Means, for example, that PLC will collect the information through the sensor. Correct? It will collect the information, and through this communication network, it is the information collected will be in the form of analog there. Okay, that is given to the master unit, and it is converted into digital form and given to the human machine interface there to display that particular information. Means this full concept or this full setup is called as the SCADA here. Means SCADA is in turn having this PLCs and the RPUs here for the collection of the data. For the collection of those devices, the data and those sensors data here. Therefore, this is the basic data flow diagram for this SCADA. Again, the components are what here. First is the PLC and RTUs. This is PLCs and RTUs interface SCADA system with the sensors. means the SCADA system is connected with the sensors through this PLCs of the RTUs. SCADA system direct sensor connect illada. Yadar through connect adagandri PLC ಮತ್ತು RTUs through. ಅದ್ರ ಥ್ರೂ ಡಾಟಾ ಫ್ಲೋ ಆಗಿ SCADA ಕಲೆಕ್ಟ್ ಮಾಡ್ತದೆ. ಈಗ SCADA ಅಂದ್ರೆ ಅದೊಂದು ಸಪ್ರೇಟ್ ಸಿಸ್ಟಮ್ ಅಲ್ಲ. SCADA ಸೆನ್ಸರ್ ಡೈರೆಕ್ಟ್ ಆಗಿ ಕನೆಕ್ಟ್ ಅದಾವ, ಸೆನ್ಸರ್ ಇಂದ ಡೈರೆಕ್ಟ್ ಆಗಿ ಡಾಟಾ ತಗೊಳ್ಳೋದಿಲ್ಲ. Sensors are connected to internal PLCs and the RTUs. Through those it is collected here. Okay. And here SCADA system with sensor. The data from the installed sensors, analog or digital, are read by the PLCs and converted to digital signals. ಈಗ ಅದೇ PLC sensor collect ಮಾಡಿದ data, that may be either in the form of analog or in the form of digital, and ultimately again that is converted into digitalized format. Okay, and these are given to the particular human machine interface there. Okay, converted to digital. These are affordable. What is advantage here? Affordable, robust, and can easily reconfigured. Okay, this can be, means cost is less here. Okay, and programming is very easy here. Next is the supervisory system. This is the one of the main part of the SCADA supervisory system. These units act as the supervisor or master of the SCADA network. Value the observe ಮಾಡೋದು correct ಆಗಿ work ಆಗ್ತಾ ಇದೆಯಲ್ಲ. Okay, main part of the SCADA network. They interface with the PLCs and issues control commands to them for execution at the actuators. These systems are configured for long-term and continuous monitoring of the system errors and the faults. Means supervisory system ಅಂದ್ರೇನು ಫುಲ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿ ಅದನ್ನ ಕರೆಕ್ಟ್ ಆಗಿದೆ, ಔಟ್ಪುಟ್ ಕರೆಕ್ಟ್ ಐತೆ ಇಲ್ಲೋ, ಕರೆಕ್ಟ್ ಆಗಿ ಸ್ಪೀಡ್ ರನ್ ಆಗತ್ತಿದೆಯೋ, ಟೆಂಪರೇಚರ್ ಕರೆಕ್ಟ್ ಐತೆ ಎಲ್ಲ ನೋಡ್ತಾ ಇರ್ತದೆ, ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಾ ಇರ್ತೈತಿ, ಮಾನಿಟರಿಂಗ್. ಅಂಡ್ ದೋಸ್ ಆರ್ ಇಂಟರ್ಫೇಸ್ ವಿತ್ ದ PLCs actuators here. ಯಾವ್ದಾದ್ರು ಏನಾದ್ರು ಸ್ಪೀಡ್ ಕಡಿಮೆ ಮಾಡಬೇಕು, ಹೆಚ್ಚು ಕಡಿಮೆ, ಇಮಿಡಿಯೇಟ್ಲಿ ಗೆಟ್ ಗಿವ್ ಕಮಾಂಡ್ಸ್ that will issue the immediately commands will be issued there, and that particular process is controlled here. Okay, that is the supervisory control. Next is the human machine interface, that is used to enable the control operations and the remote processes by human operators. Okay, means that human machine interface andrenu a full machine system ge now human beings and connected irteve, either through the computers, correct, we can control by programming, so the computer through instruction ಕೊಟ್ಟು ನಾವು ಅದನ್ನ ಕಂಟ್ರೋಲ್ ಮಾಡಬಹುದು. That is the human machine interface. And the communication interface, ಯಾವ type communication ಆಗ್ತೈತೆ ನೋಡ್ರಿ, communication is made up of the combination of the wired and the wireless connections. Wired connection ಅದಾವ communication ಮಾಡಕ್ಕೆ, ಮತ್ತು wireless ಅದಾವ, ಎರಡು ಯೂಸ್ ಮಾಡ್ತೀವಿ, both wired and the wired here. And SCADA programming, the SCADA programming language use either the C language use ಮಾಡಿ, or it's a derivative C ದ ಒಂದು ಬೇರೆ ಯಾವ ವರ್ಷನ್ಸ್ ಇದ್ದಲ್ಲ ಅದನ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ for the programming of the SCADA. Now the features of the SCADA system, that is dynamic graphical representation, means the output is in the graphical form here. Okay, the dynamic and the graphical representation, real and historical trends here, real time operations. Next, alarms and events, means the alarms and events are generated here, recipe manager and dynamic data exchange will be there, and security layer. Okay, these are the main features of the SCADA system. Means in turn these questions will be like to explain the ICS and which are the different key components of the ICS, and any one explain in detail. Any one of the components of that ICS you have to explain in detail.